All right, so for this one, it says Ronald compared the rate at which the water is used from two different water storage tanks by measuring the volume of water remaining. It looks like over time, as a result, the results are shown in the table. So you have tank one. Which statement best describes his results? So tank one, it's not arithmetic because you're going down, but it's not the same amount. In other words, if I say 340 minus, or not 340, 300 minus 240 is 60, right? So if I say 300 minus 240, that equals 60. But then if I say 240 minus 192, there's no common difference. If it was an arithmetic series, then the common difference would be the same. So because it's changing, it's probably a common ratio. So the way that I find out if it's a common ratio or not, I'll say 240 divided by 300, and that's 0.8. Now, if I say 192 divided by 240, then I get 0.8. So that one has a common ratio. So the first one has a common ratio of 0.8. In other words, for tank one, I multiply the previous term by 0.8. So my term is going to be 0.8 times the previous term, n minus 1. Okay? So in other words, I multiplied by 0.8 here. It's 80% of the previous one. And I bet you if we keep cranking through the calculator, it's always going to be 0.8, 0.8. Now this one, if you look at this one, I think this one's arithmetic in the sense that you subtract 40 every time. So let's see. Yeah, because 300 minus 260 is 40. 260 minus 220 is 40. 220 minus 180 is 40. So on all of these, you are subtracting 40 to get to the next term. So you're subtracting 40. So for tank one, it is geometric. For tank two, it's an arithmetic sequence. In other words, to get the next function, you're going to take your previous term, f of n minus 1, and subtract 40 from it. All right, so now which statement best describes this? Well, the volume of the second tank can be represented by an arithmetic sequence because the volumes in successive hours have a common difference. Well, that's true. Let's read the rest. The volume in either tank can be represented by arithmetic sequences because the volumes in successive hours do not have a common ratio. Well, that's false because common ratio. So let's make sure, because I don't want you guys to get confused on this. This is a common ratio. Common ratio means you're multiplying this by the same number. So ratio is referring to what you're multiplying by. However, this term right here, the negative 40, whatever you're adding or subtracting is called a common difference. So B says it can't be arithmetic because there's no common ratio. Well, that's just doesn't make any sense because the common ratio isn't even associated with an arithmetic sequence. I'm thinking it's A, but we'll read the rest. The volume of both tanks can be represented by a geometric. No. Tank A has a common ratio. Tank one has a common ratio, but tank two has a common difference. Tank one can be represented by a geometric. Okay, so I think, so as I read D, it says it could be a geometric sequence. So A and D seem to be the same. The difference is what's going to happen when I multiply 192 by 0.8? Will I get 153.6? I didn't check all the terms, so let's check. So what is it that I need to multiply 192 by 0.8? So so I'm going to say 192 times 0.8. Ooh, times 0.8. Well, that's correct. Oh, we got to read it carefully. So look at this. Same thing as B. It says it can be represented by a geometric sequence because it has a common difference. Mr. Adams was acting like a student. I didn't read the sentence all the way through. Well, geometric sequences have common ratios. They don't have common differences. Common difference is only associated with arithmetic. So A is the correct answer. A is definitely the correct answer.